Originally, as Mr. Katayama said, we had an earlier deadline of 2006 for the transition to complete. No one really thought that that deadline was realistic when it was adopted. It was a political compromise, but it got the process started. So then the Congress in the US took the issue up again and ultimately decided on a firm, hard deadline of February 2009. So in less than a year, analog broadcasting is scheduled to be shut off in the United States. And as part of this process, the analog broadcast spectrum will be returned for reallocation. There are also some mechanisms to deal with some of the costs and difficulties of the transition. One is a consumer education process with commercials and other mechanisms to help people understand what this transition means. The other is a subsidy program to provide coupons for the digital converters that will be necessary to use an analog set. But the coupons are only for $40, which doesn't cover the entire cost of the converter. The decision that has been made is that even though there's a cost for people to make this transition, it's important to ensure that it happens. So how did this process work? In many ways, there were problems. The transition, as I said, had to be extended from what was originally promised when the process was set up. In order to get the broadcasters to go along with the transition, the government had to give them, for free, new spectrum for the duration of this process. This was very controversial at the time because, as I said, the ultimate goal of this policy is to make more capacity available. And the transition limited use of both the analog and the digital band to this television transition for roughly 13 years. And the broadcasters spent all this money for something that only affects a small percentage of the people in the country. Most people aren't even watching television over the air in the United States, and as a result, there's a great deal of confusion about what this transition means. The good news is that it's worth it. Because we went through this process, the transition that I've described could start to happen. Again, we were fortunate in the timing because of the transition in TV equipment technology from CRT to flat panel. So people had reasons to buy a new television set, even independent of the digital transition, but the two things helped reinforce each other. So probably the fact that these new TVs could receive the digital signal was an incentive for many people to buy them. So I think the policy has been very good for many Japanese companies as well that manufacture these TV sets, even though that's not what the US government was trying to do. So the transition is happening in the US finally in terms of the sets. It's also happening in terms of the application moving away from traditional broadcast television. The broadcasters generally have begun digital broadcasts on schedule according to the plan. At the same time, the rapid growth of internet-based video has allowed most people to appreciate that television is not just a traditional, non-interactive, linear experience. The other thing that happened in the US is that cable and DBS satellite, which weren't part of this mandated transition, moved to digital as well. They see digital as a big market opportunity. And the final good piece of what's happened in the US is that as we now near the end of the transition, that analog spectrum can be freed up. The first piece of spectrum to be returned is some UHF spectrum in the 700 megahertz range. Earlier this year, the FCC held auctions for this 700 megahertz spectrum. No one bid on this spectrum to do television. They bid on the spectrum to do broadband wireless internet. So this is the real benefit from this transition. Because we've moved from traditional television to this digital world, the connection between certain blocks of spectrum and traditional television service has been broken. As I said, ultimately in this world, what matters is capacity. And the television broadcasters themselves in the United States showed that this was the case. They advocated not even necessarily moving to high definition, but to multicasting multiple channels on the digital spectrum, because they realized that the most important thing is to be able to use spectrum capacity as actively as possible. The broadcasters have also been very aggressive in ensuring that their digital signals get carried on the cable networks. Again, they realize what matters is capacity, not the traditional broadcast service. And this auction of the 700 megahertz spectrum started to allow some new entrants to get involved in the process. Although they didn't win the auction, Google bid over $4 billion for some of this 700 megahertz spectrum. And several other innovative new companies were established with new models for using this wireless capacity in ways that look very different from today's existing carriers. This is what happens when the process allows the capacity to be made available, and the spectrum policy allows it to be made available to those who value it and can use it the most. And the final piece of the transition that is happening is the transition of the devices. A range of new kinds of devices that use television in new ways. Some of these are sold to people as a television enhancement, like a TiVo device. And some of them are sold, for example, as a video game console, but one that connects into the television set. The point is, once you think of television as a large, high-resolution screen that has a network connection onto it, great new innovations become possible. And we're starting to see that happening now in the marketplace. So, as I said, again, it's not about television. Where do we go next? I think we go further into appreciating the importance of this spectrum policy reform I described. As I said, this digital networked age is an age of abundance. All of our business models and policies about communications, and especially about broadcasting, have been based on the idea that spectrum is scarce. This is true not just in the United States, it's true in Japan, it's true in basically every country around the world. And maybe spectrum was scarce 50 years ago or more when some of these technologies originally came into the marketplace. But spectrum is not scarce because of some fundamental physical limit. We make spectrum scarce through technology and through mechanisms of using it. And we also make spectrum scarce through regulation. The challenge for policymakers today is to make spectrum abundant. Let me give you a few examples of why there is vastly more wireless capacity than we're using today. These are some numbers mostly from the United States, but in Japan the situation in many ways is even worse. The United States is a very large country, and so it's actually hard to use spectrum efficiently. In many ways, it would be easier here to get even more capacity. So here's the data that we have in the US. On average, 95% of the most valuable spectrum bands are not in use on any given day. This was a study that was done in 2005 by a group that sampled actual transmissions in the spectrum in a number of cities in the US. And if you think that that's just because there's some rural areas that are not very populated, in Manhattan, the most busy area for use of the spectrum, 87% of the frequencies were not in use. If you look at a chart, you will see that there are services that have that spectrum allocated, but when you look at where the actual transmissions are, you see that they are not happening most of the time. That's for the spectrum as a whole. For broadcasting, in many ways, it's even worse. So, for example, as I said, there are 67 VHF and UHF broadcast channels in every market in the US. On average, there is no station operating in 9/10 of them. And the most populated city, 2/3 of the spectrum channels are empty. That spectrum is being wasted. Capacity that could be available for new services and new competitors, and yet it's been allocated to traditional broadcasting.